Hello students, today we will discuss about one important topic of emulsion chapter, that is physical instability marker. So before going to that topic, first you have to know what is emulsifying agent. Then we will go for that physical instability marker one by one. So what is emulsifying agent? Emulsifying agent is nothing but that is used for preparations of emulsion. Different types of emulsifying agents are there. Ionic type emulsifying agent, we know that cationic type emulsifying agent, anionic type emulsifying agent, non-ionic type emulsifying agent. Different types of emulsifying agents are there. In HLB scale also we have seen that two types of emulsifying agents are there, O by W and W by O. And Bancroft's rule, already we have covered that part. Bancroft's rule, what it says, according to that Bancroft's rule, we know that the type of emulsion formed completely depends on the type of emulsifying agent used. For example, we have used O by W type of emulsifying agent. For example, twin 20, 40, 60 and 80. So if we use this O by W type of emulsifying agent, the type of emulsion that will form, that will be also O by W. And examples of W by O type of emulsifying agent, that is spun 20, 40, 60, 80. All are lipophilic in nature. So if we use the spun for preparations of emulsion, the type of emulsion that will be W by O. So this is all about emulsifying agent. Now so finally we can say that emulsifying agent help to stabilize the emulsion. But in spite of best effort, emulsion tend to be unstable. What are that reason? The reason is 5 instability marker. Here we can see first one is flocculation, second one creaming, third one coalescence, next breaking, and fifth one is phase inversion. So one by one we will discuss about that. First we will study about what is flocculation. Flocculation, that is the first step of instability of one emulsion. What will happen? In this case, neighboring globules come closer to each other and they will form colony in the external phase. We know that in emulsion two phases are there because it's a biphasic liquid dosage form. One is internal phase, another one is external phase or dispersion medium. Now in internal phase, the neighboring globules, they will come closer to each other and they will form colonies. But in naked eye, that is not visible. This aggregation of all the globules is not clearly visible. This is probably the initial stage that leads to instability. Now, this formation of flocculations or the extent of flocculations of globules, that depends on some factor. So what are the reason behind this flocculation? First reason is globule size distribution. Second reason, charge present on the globule surface. And third reason is viscosity of external medium. In micromatrix chapter also, you have already performed the practical, that is particle size determinations. And in cases of powder also, what we have seen, that if the powder is monodisperse, then the solubility will be higher than polydisperse powder. So same here also, if all the globules present in an emulsion that is same size, then the stability of the emulsion that will be automatically increased. Uniform size globules prevent flocculation. Now how to achieve that? This can be achieved by proper size reduction process. In pharmaceutical engineering subject, already you have studied about that different size reduction process. One process, I think all of you remember, homogenizer. So by using homogenizer, if we prepare emulsion, in that cases the globule size that will be uniform. And during these preparations of emulsion, a charge that may produce on the globules which exert repulsive force with the neighboring globules. Now another one point is there, this charge that may produce on the globules that may be achieved by using some ionic emulsifying agent or sometimes by adding some electrolyte. So if we add some electrolyte or if we use different ionic type of emulsifying agent, so then the charge that may produce on the globules. If the viscosity of the external medium is increased, that is the third factor, the viscosity of external medium, if it is increased, then the globules become relatively immobile, and if all that globules are immobile, then flocculation can be prevented. So these are the three factors on which the formation of floccules depends on: globule size distribution, charge on globule surface, and viscosity of external medium. Now, how to increase that viscosity of external medium? By using some thickening agent, for example hydrocolloid and wax. If we add hydrocolloid or any wax on the external surface, then the viscosity of external phase that will increase. The flocks slowly move either upward or downward, which leads to creaming. That is the second instability marker of one emulsion. Flocculation should not be confused with creaming. Why? Because first thing is formation of flocks. After formation of flocks, all that flocks slowly move either upward or downward, which leads to creaming. So that's why I am telling flocculation should not be confused with creaming. So what is the difference? Flocculation is due to the interaction of attractive force and repulsive force, whereas creaming is due to density difference in the two phase, water and oil. Again I am repeating, the difference between flocculation and creaming is, flocculation is due to the interaction of attractive force and repulsive force, whereas creaming is due to the density difference in the two phases, oil phase and aqueous phase. So second instability marker is creaming. Creaming is the concentration of globules at the top or bottom of the emulsion. If all the floccules goes upside, then upward creaming will happen, and if it goes downside or downward, then downward creaming will happen. The floccules move either upward or downward, which leads to creaming. This creaming may also be observed on account of the movement of individual globules also. It can be observed by a difference in color shade of the layers. From the figure already we can see that two colors are there, one is red color, another one is light blue color. So two layers are there. So creaming can be observed by a difference in the color shade of the layer. It is a reversible process. Reversible means after agitation, again all that cream that is formed upside or downside, that will be redispersed very easily. This is possible because the oil globules are still surrounded by the protective sheath of the emulsifier. So that is the reason that after agitations, again all that cream that will be easily redispersed. This is possible because the oil globules are still surrounded by the protective sheath of the emulsifier. So this is a potential step towards complete coalescence of internal phase. So hence this stage is also considered to be the mark of instability. Another one important point is, in creaming the drug is not uniformly distributed. This leads to variable dosage. Therefore the emulsion should be shaken thoroughly before use. So already I told creaming is two types, upward and downward. Upward creaming, this is due to the less denser internal phase, example oil, because oil is less denser than water. This is normally observed in O by W type of emulsion. On the other hand, downward creaming is also possible if the internal phase is heavier. Due to gravitational force, the globules will settle down at the bottom of the bottle. This is normally in cases of W by O type of emulsion, since creaming process involves the movement of globules in an emulsion. In suspension chapter and micromatics chapter, already you have seen that Stokes law. So in this case, the Stokes law that can be applied. Now some reasons are there. Because of that reasons, creaming is influenced. So creaming can be influenced by some factor: globule size, viscosity of dispersion medium, and difference in density of dispersed phase and dispersion medium. These are the three factors on which creaming is depends on: globule size, viscosity of dispersion medium, and difference in density of dispersed phase and dispersion medium. Now, creaming that can be prevented. How? Three different methods are there. The first method, reducing the particle size. How to do that? By using homogenization technique. By using homogenizer, we can reduce the globule size of internal phase. So this is the first step. Second method, by increasing the viscosity of external phase by adding some thickening agent, example tragacanth or sodium alginate. So if we add this tragacanth and sodium alginate, the viscosity of external phase that will increase. So creaming can be prevented. Sorry. And third method, reducing the difference in density between the dispersed phase and dispersion medium. In general, the density of aqueous phase is higher than oil phase. So to make the density equal, oil soluble substance, for example beta bromonaphthalene, bromoform, that can be added to the oil phase. If we add this substance, the density of oil phase that will increase. This technique is rarely used in practice. So this is all about creaming. Next I am coming to the point, that is coalescence. So what is coalescence? A few globules tend to fuse together with each other and it will form bigger globules. From the figure already we can see that two globules are there, they will fuse together and they will form one bigger globules. In this process, the emulsifier film around the globules is destroyed to a certain extent. But in cases of creaming, what we have seen, the protective sheath that will not be destroyed. But in this case, it will be destroyed up to a certain extent. This step can be recognized by increased globule size and reduced number of globules. Obviously, if globule size is increased, the number of globules that will decrease. So coalescence is followed by creaming stage. Now what is the reason behind this coalescence? The coalescence is observed due to three reasons. First reason is insufficient amount of emulsifying agent. Second point, altered partitioning of emulsifying agent. And third one, incompatibilities between emulsifying agent. During preparations of emulsion, if we use insufficient amount of emulsifying agent, then coalescence that may happen. And second point, altered partitioning of the emulsifying agent. This point is very important. Listen carefully. Altered partitioning of the emulsifying agent, because we know that according to HLB scale, two types of emulsifying agents are there, O by W type and W by O type, or hydrophilic and lipophilic. So depends on that emulsifying agent type, they will partition in aqueous phase as well as oil phase. If the emulsifying agent is lipophilic, obviously the maximum portions that will goes in oil. And if it is hydrophilic in nature, emulsifying agent, then maximum portion that will be partitioned in water or aqueous phase. So if this partitioning of emulsifying agent is altered, then coalescence that may happen. And third point is incompatibilities between emulsifying agent. For example, we have prepared one emulsion and that contains one combination of emulsifying agent. So if there is incompatibility is present in between that emulsifying agent, that means both emulsifying agents are not compatible with each other. In that cases, coalescence that may happen. And in this case, another one important point, that is phase volume ratio, which represents the relative volume of water to oil in an emulsion. A higher ratio globules are closely packed, wherein small globules occupy the void space between the bigger globules. Thus, globules get compressed and become irregular in shape, which leads to fusion of adjacent globules. So this is all about coalescence. Next instability marker is breaking. From its name itself, what we can say, that is complete separation of aqueous phase and oil phase. So breaking is indicated by complete separation of oil and aqueous phase. It is an irreversible process, but in cases of creaming, what we have seen, that is a reversible process. but breaking is irreversible process. Simple mixing fails to resuspend the globules into an uniform emulsion. In breaking, the protective seal around the globules is completely destroyed. Because of that, it is a irreversible process. Another one point that I have not included here, that is phase inversion. Phase inversion involves the changes of emulsion type from O by W to W by O, or vice versa. For example, we want to prepare O by W type emulsion, but after preparation, if the final emulsion turns out to be W by O, it can be termed as sign of instability. In dispensing pharmacy, already you have prepared cold cream, so that is one examples of phase inversions. After application to the skin, the type of emulsion that will changes. So this is known as phase inversions. Next topic is factors improving emulsion stability, that we will cover in next class. Thank you, students.